Welcome back. In this video, we are going to solve problem 6-141 that is taken from chapter number 6 Bending and book name is Mechanics of Material by R.C. Hibbeler, 9th edition. So topic is curved beam. Statement is if P is equal to 3 kilonewton, determine the bending stress developed at point A, B and C of the cross section at section AA. Using this result, sketch the stress distribution on section AA. So you can see this is a curved beam that is acted upon by this load P, which is given as 3 kilonewton. So at section AA, you have to determine the bending stress at point A, B and C. And after finding this, you have to determine the stress distribution on section AA. When you section it, the cross section is shown over here. So let's start with the solution. The formula that we will use in this curved beam is this one. This is the formula for bending stress, where you have M, which is moment, capital R minus small r. So small r is distance. You can see this is a curved beam, so its radius of curvature is given as 300 millimeter. So this is center of curvature. So capital R is distance from center of curvature till the point where its neutral axis lies. And what is this small r? So small r is distance from this center of curvature to every point where you want to find the stress. Just like here, you can see we have to find the stress at point A. So it will be RA. At point B, it will be RB. And at point C, it will be RC. Clear? And R dash is distance from the center of curvature till the centroid of this section. So let's start with the solution. What will be the first step is that if you cut this curved beam at section AA and draw the free body diagram I have drawn over here. So you will see you will having a shear force V at section AA, which will act upward. So it will be VA dash A, and you will be having a moment in clockwise direction. This is equal to MAA. So we'll find this moment because this internal moment will cause bending effect. So we'll find this by using equation of equilibrium, that sum of all moments about neutral axis is equal to 0 and taking the counterclockwise moment as positive. So you can see the first moment is due to this P load and perpendicular distance is this 0.6 meter or 600 millimeter. Clear? And that is producing counterclockwise effect, so it will be positive. So I will write P into 0.6. The second moment at this neutral axis will be this moment MAA dash, that is clockwise, so it will be MAA. Their sum must be equal to 0. So from here, this moment MAA will be equal to 0.6 times P. Now you know the value of P, that is given as 3 kilonewton. So just put it 0.6 into 3 kilonewton will give you 1.8, and the unit will be kilonewton into meter. This is moment at point AA. Okay, now you have this moment. So you can see that due to this moment that is acting like this, and due to this load, the moment will act like this. So it will produce bending effect. So I will draw it over here. Here the moment is like this, and due to this load, the moment is like this. So it will cause this bending in this curved beam, and it will try to straighten this curved beam. So the top, these two portions will be in tension, while this point C will be in compression, because the top layer is going to stretch while the bottom layer is compressed. So C is in compression while A and B is in tension. So we'll find them one by one. So we have this moment M. So by using this formula, you can see we have find out the M. Now we will find this capital R, and you can see we have another term E, which is equal to R dash minus R. What is R dash? So R dash is distance from this center of curvature to the centroid. So we will find this R dash first. So R dash is equal to, let me write it, distance from center of curvature . to the centroid of section. Okay, as we know that we have this section, so you can see this is T shape. So if I draw a horizontal line from this center of curvature, and you can see this is T section, so let we divide it into two portions. The first one is this one and the second one is this one. So we know that its centroid can be obtained by using this formula, which is equal to R dash will be equal to Y1 dash into A1 plus Y2 dash into A2 divided by sum of area, which is A1 plus A2. Now what is A1? So A1, you can see this is 20, this is the thickness is 20 millimeter. This thickness is 20 millimeter and this width is 75 because 25 plus 25 plus 25 is 75. So I can write A1 is 20 divided by 1000 will give you in meters. So 0.02 multiply by 0.075 meter. Similarly, you can see A2 is equal to, let me zoom it. You can see A2 is, area 2 is 25 millimeter by 50 millimeter. So I will convert them into meter. Clear? Okay. So A2 is 0.025 meter multiplied by 0.05 meter. And then unit will be square meter and here it will be also square meter. Now what is Y1 dash and Y2 dash? So Y1 dash is distance from this center of center of curvature to the mid of first section. So this is the mid of first section. So you can see that this distance from centroid curvature is 300 millimeter and half of 20 is 10. So this will be equal to 310 millimeter. So I will write this will be Y1 dash and Y1 dash will be equal to 310 millimeter, or that is equal to 0.310. What is Y2 dash? So Y2 dash is distance from center of curvature till the centroid of second section. So this is Y2 dash. Let me write it first. Y2 dash and Y2 dash, you can see that this will be equal to 300 plus 10 is 310 and the half of 25 is 310 plus 25 is 330, 340, 335. Okay, no. 30 up till now this plus 20 is 320 and 25 is this, so 345. So I will write Y2 dash is equal to 345 millimeter. So I will write them downward. Clear? Okay. So Y1 dash is equal to 0.310 meter and Y2 dash is equal to 0.345 meter. Now you have all the value, you can just plug it in this formula. So Y1 dash is 0.310 multiplied by area 0.02 into 0.075 plus our Y2 dash 0.345 into A2, which is 0.025 multiplied by 0.05 divided by the area A1 and A2. So you can see A1 is 0.02 multiplied by 0.075 plus A2 is 0.025 multiplied by 0.05. Okay, so when you solve this, you will get R dash comes out to be 0.325909 meter. So it is basically the distance between center of curvature till the centroid of first section. So let me delete these things. You have now a clear understanding. So we found out that distance from this is the centroid, which is C. So distance from the center of curvature till the centroid is R dash. Clear? R dash. So we have find out this R dash comes out to be 0.2 325,909 meter. Okay, so what we will find is that we have find out this one. So we'll find this R, and R is equal to, you can see you have this formula. So I will write it. R is equal to area divided by integral of dA over R over area A. And as we know that area, I will choose another color. Area is equal to, total area is equal to A1 plus A2. So A1 is 0.02 multiplied by 0.075 plus A2 is 0.025 multiplied by 0.05. Okay, so when you solve this, you will get this area, total area comes out to be 2.75 into 10 raised to power minus 3 unit will be square meter. Now what about this term that is given in denominator, which is integral of dA over R for the entire area? So you can see we can find this by using this table 6.1. Here there are shapes and their formula for integral of dA over R for the entire area. Since you can see we have two portion, 1 and 2, and both are rectangle, so what we will do is that we will use this formula. So formula for this. So now this is the line which is passing through the center of the curvature. So you can see from the center of curvature, the first side or first portion of this rectangle is at a distance of R1 and second one is at a distance of R2, and the width of this rectangle is B. So we will take these values over here. You can see that for the first, this is the breadth which is total 75, clear, and this will be R1. R1 will be how much? It will be 0.3 meter. And what is R2? So R2 is distance from center of curvature till the second portion of the rectangle. So total will be 20 plus 300 is 320. So breadth is 75. So I will write it is equal to, breadth is 75, so which is 0.075, clear. And the formula here is this one, B into ln of R2 or R1. So B is 0.075, ln of R2 was 0.32 divided by R1 was 0.3, clear. Plus, now we have another rectangle, this rectangle. So you can see R1 will be this one, this will be R1, which will be equal to 320 millimeter or 0.320, and R2 will be distance from this center of the curvature till this. So this total height is 50 plus 20 plus 300 is 370. So R2 will be 0.370. And what is the width or breadth? So it is 25 millimeter. So I will write it. 25 millimeter is 0.025 into ln of R2 or R1. So R2 was 0.37, clear, divided by R1. R1 will be, R1 was 0.32. Okay. So when you solve this, you will get integral of dA over R for the entire area comes out to be 8.46994 into 10 raised to power minus 3. Now you have the value of A and this integral, so just plug it in this formula. So I will write it 2.75 into 10 raised to power minus 3 divided by 8.4699 into 10 raised to power minus 3. Okay. So when you solve this, you will get this R will be equal to 0.324678 meter. And what is this R? R is distance from centroid of the center of curvature till the neutral axis. So as R is less than this, so it will be somewhere here. It will be somewhere here. This will be your R, capital R. Okay. Now we have these values, both values, E this value. So E will be equal to R dash. R dash is how much? We have calculated R dash is this one. So 0.325909 minus capital R is 0.324678. So when you calculate it, you will get this E will be equal to 1.2314 into 10 raised to power minus 3, and the unit will be meter. Now you have all these things, so just put it in this formula. I will write the formula downward or on next page. So formula for stress is equal to M into capital R minus R divided by AE into R. Okay, number one, for point A, the stress for point A. So R will be equal to RA. And you can see that at point A, the R will be, this is point A. You can see this is point A. So R will be 300 millimeter. So I will write, put R is equal to 300 millimeter or 0.3 meter. And put the value. So sigma A will be equal to, what was the value of moment that we calculated? If you remember, 1.8 kilonewton. This is the value, 1.8 kilonewton. So 1.8 into kilo is 10 raised to power 3 multiplied by capital R was 0.324678 minus RA is 0.3 divided by area. So area we calculated was 2.75 into 10 raised to power minus 3 multiplied by this E, which is 1.2314 into 10 raised to power minus 3, and RA is 0.3. Okay, so when you calculate it, you will get stress at bending stress at point A comes out to be 43.7 megapascal. So the value is plus that. It means that point A is in tension. Okay, we will move towards second part. So that is for point B, stress for point B. So at point B, we have R is equal to RB, and let me show you that RB is at this distance. So this is 300 plus this thickness was 20. So 320 millimeter, or that will be equal to 0.320. So put it in this formula, you will get stress at point B is equal to moment into R minus RB divided by area E into RB. So put the value, M is 1 into 10 raised to power 1.8 into 10 raised to power 3 multiply by R is 0.324678 minus RB is 0.320 divided by area, which is 2.75 into 10 raised to power minus 3 multiply by E, which is 1.2314 into 10 raised to power minus 3 multiply by RB is 0.320. So when you solve this, you will get stress at point B comes out to be 7.77 megapascal. And this value is also positive, so it means that point B will be in tension. Okay. The last part is that we have to find the stress, bending stress at point C. So for point C, R will be equal to RC, and you can see that RC is this distance from top till the end. So this total distance is 300 plus 20 plus 50, so 370. So RC is equal to 370, which is equal to 0.370. Okay, so again put it in this above formula. So sigma C will be equal to M is 1.8 into 10 raised to power 3 multiplied by capital R is 0.324678 minus RC is 0.370 divided by area, which is 2.75 into 10 raised to power minus 3 multiplied by E, 1.2314 into 10 raised to power minus 3 multiplied by 0.370. So when you solve this, you will get this stress comes out to be negative, because this value will give you minus. So this will be equal to minus 65.1 megapascal. Or you can also write it that sigma c is 65.1 megapascal, and instead of negative you can write that point C is in compression. Okay, now you have all these values. So this is the answer of our first part. In second part we have been asked to determine the sketch distribution on section AA. So what if I draw section AA like this? For example, if this is the beam, clear? So when you cut it and draw it like this, so I will take this initial section is like, and this will be curved like this. Let this is its neutral axis. At this point it has a neutral axis. This is your point A, this is your point B, and this is your point C. So at A we have 43.7 megapascal. So it will be like this. Let this is 43.7 megapascal. And at neutral axis we have 0, and it will be like a parabolic curve. It will be like this. Okay. At point B we will have 7.77 megapascal, and till neutral point it will become 0. Now at C we have a compression. So you can see at point C this is equal to 65.1 megapascal, that is in compression side. So this curve will be like this. It will be like this. Okay. So this is the stress distribution along section AA. This was section AA. And that was all about this problem 6-141. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it, and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching.